In this video, we will learn about the concept of electric current from chapter Electricity, class 10. So, first we understand what is electric current. You might know the general meaning of current. Current means flow, whereas electric gives the meaning the charge, nothing but charges. So, if charges flow, in simple, we can call it as electric current. You all know that the metals are good conductors of electricity. They can conduct the electricity due to the presence of free electrons in them, where the electrons will flow freely in conductors. Whereas if you connect this, let's say this is a conductor and it is connected for a power source like battery, then all the electrons will start to move in a specified direction. You see here, this white dotted circle, assume them as charges, that is free electrons. And you see that all they start to move in a specified direction through the conductor. So the number of charges that flow through the conductor in unit time, that is total charge. What you say? Total charge that moves through the conductor in unit time. We can say that it is electric current. The electric current is equals to the total charges that are moving through the conductor in unit time. Okay. So this is the meaning of electric current, whereas we see the definition of electric current and a few more terms that are related to the electric current. Yes, you see here, the electric current is the rate of flow of electrons. Rate of flow of electrons. That means, as we discussed, number of electrons that flow through the conductor in unit time. That is rate of flow of electrons. That is the meaning of rate of flow of electrons. So that you can define the electric current with this statement. As I told you, this is the mathematical expression of electric current. That is I is equals to Q by T, where I is taken as electric current, Q is total charge, T is time interval. Whereas the SI unit of electric current is ampere. Ampere. It is denoted with the letter capital A. And we need a device to measure electric current, right? So that device used to measure electric current is named ammeter. Ammeter. So here you can see a picture of ammeter. It seems to be like this. So this is the device used to measure the electric current. Whereas ammeter is always connected in series connection. Ammeter is always connected in series connection. Why it is always connected in series connection? Because it has a very low resistance so that it won't affect the flow of charges through the conductor. As it has low resistance, it won't affect any flow of charges through the conductor. And when it comes to the symbol of ammeter, the symbol of ammeter while drawing the circuit diagram, you can take this. That is, this will be the symbol of ammeter. Let's say one end is considered as positive terminal of ammeter, one end is considered as a negative terminal of ammeter. Fine. So now we got a mathematical expression, definition, unit, and you know how to measure the electric current using ammeter and how it is connected. Now we see a basic numericals related to this concept. Let's see question 1. A current of 0.5 amperes. What they have given? Current of 0.5 amperes flow through the conductor for 5 minutes. So The time interval is 5 minutes. What you need to calculate? Calculate the amount of electric charge that passes through the conductor during this time. That is, if 0.5 amperes of current is passing through the conductor for 5 minutes, what will be the amount of electric charge through that conductor, right? That is, you need to find the charge, electric charge. So what is the mathematical expression for finding the electric current? I is equals to Q by T. That is charge by time. But here we need to find the electric charge, amount of electric charge, right? So that if you take this T to the LHS, so what it will become? Q is equals to I into T. So this mathematical expression can be further taken like this. That is Q is equals to I into T. So whereas now we will plug in the values. What is I here? 0.5. What is time? So before taking this value of T, they have given it in minutes, right? So that first we need to convert it into seconds. 1 minute is equals to 60 seconds, so that we can multiply 5 into 60 seconds. So what you will get here? 5 6 are 30 and 0. That is 300 seconds. Now I'm going to take this value, 300. Let's say 1 0, and I'm just taking out the decimal here so that it becomes 5. 5 3 are 15, 5 0 0. That is total charge. What you got here is 150 coulombs. 150 coulombs is the total charge. Done. We see one more numerical related to this concept. Let's say question 2. Here the number of electrons are given. That is 1.2 into 10 power 20 electrons flow through a wire in 2 minutes. Let's say the number of electrons, N is equals to 1.2 into 10 power 20 number of electrons are flowing through a wire in 2 minutes. That is time. I will convert this minutes into seconds. 1 minute is equals to 60 seconds, right? So that what you will get? 2 6 are 12, 120 seconds. Now what we need to find? What is the magnitude? What is the magnitude of electric current? What is the magnitude of electric current flowing through the wire? That is, we need to find electric current I. And we know that charge on one electron is minus 1.6 into 10 power minus 19 coulombs. So before finding current, we need to find the total charge, right? Q is equals to N into magnitude of one electron. That is number of electrons. How many number of electrons given? 1.2 into 10 power 20. So these number of electrons, when they flow through the conductor, what will be the charge developed in that conductor, right? So each electron has a magnitude of minus 1.6 into 10 power minus 19 coulombs, right? So further, if you solve it, let's say minus, I will multiply this 1.2 with 16. Let's say 16 to the 32, right? Yes. Next, here 3. 16 ones are 16 and 19. So you have a decimal part here, that is minus 1.92 into 10 power 20 into 10 power minus 19. You will get 10 power 20 minus 19 coulombs. So further, if you solve this, the total charge will be minus 1.92 into 10. So finally, what you will get, if it is multiplied with 10, minus 19.2 coulombs is the total charge. Now we got total charge. Then we will see what is the total current passing through that conductor then. I is equals to Q by T. What is Q here? We got 19.2 by, what is the total time? 120 seconds, right? 120 seconds. So to remove out this decimal, I just want to multiply with 10 and divide it with 10, so that I will get 192 by 1200. So if I solve it further, I will get, let's say 0. Right? 192 is less than 1200, so that 0 point. So what you will get, it become 1920, that is 1920. So 1200 into 1. If you subtract 1920 and 1200, you are going to get, that is 620. So it becomes 6200 then. I will take it 5, that is 1200 into 5. So that, let's say we can stop it with this. So you will get some other decimal. Approximately, you can say that the total current passing through the conductor is 0.15 amperes. 0.15 amperes is the total current passing through the conductor.